In this video, we'll look at configuring serial communications for the G500 and G100 devices. First, we'll provide an overview and then look at physical serial ports, virtual serial ports, port settings, adding a serial connection, modifying or deleting a serial connection, application parameters, connection security, redundancy via dedicated link and switch panel, and lastly, we'll cover the terminal server. With that said, let's jump in and get to it. Each serial port on the MCP G500-G100 can be assigned to either a single SCADA protocol server application for master station communications or a single device protocol client application for device communications using a standard serial connection. The MCP supports the following types of serial connections: point-to-point serial communication, connections between two devices or nodes; multi-drop. Some devices support a daisy chain connection in which multiple devices are wired together from one to the other. A multi-drop configuration requires additional configuration to set up each individual device on a multi-drop connection. Multi-drop with dial-up modem. A multi-drop communication using dial-up modem connection. Redundant communication. Communications that take place over a serial connection can be configured for redundancy by setting up two serial ports, a primary port and a secondary backup port. Communications normally take place over the primary port. In the event of a loss of communication with the device over the primary port, the MCP tries to reestablish communication over the secondary port. If the MCP cannot reestablish communication over the backup port, it reports the device status as offline. Serial connections can be configured using the following protocols or functions: client application, DNP3 multi-drop, DNP3 multi-drop modem, IEC 60870-5-101 multi-drop, IEC 60870-5-103 multi-drop, generic ASCII, SEL binary, MCP as a master server application, DNP3 master station, DNP3 master station modem, IEC 60870-5-101 master station, Modbus serial master station, Tejas V master station, terminal server, others, logic links device, redundancy dedicated link, and redundancy switch panel. The G500 has 8 native serial ports and can have up to 12 additional serial ports using PCIe expansion cards for general purpose serial communications. The G100 can have a maximum of 4 serial ports for general purpose serial communications. Depending on the configured model in the order code in the MCP Studio/Devices Properties, the ports which are not available in the order are shown grayed out when configuring serial connections. The mode of each serial port, RS-232, RS-422, /RS-485 2-wire, /RS-485 4-wire, and its termination is configured using the MCP Local Configuration Utility, or MCP CFG, or the MCP Settings GUI. The default is RS-232. MCP devices have a dedicated serial port reserved for settings and maintenance operations. For G500, this is the front USB Type B port, and this serial port cannot be used for other purposes in the G500. For G100, this is by default serial port number 4. When enabled, or default, serial port number 4 cannot be used for other purposes. It can be disabled and made available to other applications when configuring connections. The serial ports are indicated by numbers or a combination of letters and numbers as shown below. Ports 1 to 4, basic serial ports on G100 and G500. Ports 5 to 8, G500 only, basic serial ports. Ports A1 to A4, G500 only, port 1 to 4 on the serial expansion card in PCIe slot 1. Ports B1 to B4, G500 only, port 1 to 4 on the serial expansion card in the PCIe card slot number 2. Ports C1 to C4, G500 only, port 1 to 4 on the serial expansion card in the PCIe slot number 3. The Virtual Serial Ports feature allows you to communicate with devices through an Ethernet connection even though they appear to be connected through a physical serial port. For example, virtual serial ports can be used to eliminate copper wire communications to feeder bays when a serial-only device is located in the bay. A small terminal server can be placed in the bay and connected to the Ethernet network, allowing MCP serial client applications to connect to the serial device. Virtual serial ports can also be used to expand the number of serial ports that the MCP can communicate over. You can use the virtual serial ports for any connection except for system redundancy and modem links, and you can create up to 150 virtual ports. To create a virtual serial port, 1. Access the Connections tab of the configuration page. If there are no connections on this page, you must create one. 2. Click the Virtual Serial Ports tab. This tab is available on all serial connections. 3. Click the Add button and configure the newly created row. 4. You can now select the virtual serial port as the primary backup port on the Serial Connections tab. The virtual serial port settings include virtual serial port number, the port number assigned to the virtual serial port. VP1 to VP150 are reserved for virtual serial ports. The default is lowest unused virtual port number starting from VP1. IP address. The valid IPv4 address to use to connect to the device. The default is 127.0.0.1. Network ports. The network port to connect to on the remote IP address. The range is 0 to 65,535. The default is 10,100 plus the pre-assigned virtual serial port number. Please note, do not configure any hardware handshaking operations on serial connections that use virtual serial ports. Doing this prevents the virtual serial port from initializing and the client or server client application configured for the port fail to start. The following serial port settings are required for each connections. They define how the MCP communicates over the serial link. Primary port, primary serial port for device communications. It can be physical serial ports or virtual serial ports. The default is incremented from 1 for physical serial ports and incremented from VP1 for virtual serial ports. Backup port, secondary port for device communications if the primary port fails. The backup port automatically takes on the settings of the associated primary port. It can be physical serial ports or virtual serial ports. The default is empty, non-redundant communications. Baud rate, the speed of information being transmitted across a serial connection in bits per second. The range is from 200 bps to 115,200 bps. The default is 9,600. Parity, a bit added to a group of bits to detect the presence of an error. The options available are even, none, and odd. The default is none. Data bits, number of bits used for each character. The options available are 7 and 8. The default is 8. Stop bits are the number of bits used to indicate the end of each character as it is transmitted. The options available are 1 and 2. The default is 1. Some protocols may require RTS, CTS, and DCD parameters to be configured. When the serial port is configured for RS-485, modem control handshaking signals RTS, CTS, and DCD generally do not apply. The exception is with the DNP server, where the RTS pre-trans delay can be used to slow down the server response. This is sometimes necessary in 2-wire setups to prevent the DNP server from responding while the master is still driving the line. For RTS values, flow control specifies whether RTS flow control is enabled. The default is disabled. Pre-trans delay, MS, specifies the time in milliseconds that RTS is asserted before data is transmitted, also known as the RTS preamble. The range can be 1 to 65,535 ms. The default is 15 ms. Post-trans delay specifies the time in milliseconds after data is transmitted that RS is held asserted, also known as RTS postamble. The range can be 1 to 65,535 milliseconds. Default is 15 milliseconds. For CTS values, flow control specifies whether CTS flow control is enabled. The default is disabled. For DCD values, flow control specifies whether DCD flow control is enabled. The default is disabled. Receive inhibit delay specifies the receive inhibit delay in milliseconds. The range can be 1 to 65,535 milliseconds. The default is 15. Minimum backoff delay specifies the minimum backoff delay in milliseconds. The range can be 1 to 65,535 milliseconds, and the default is 15. Random back-off delay specifies the random back-off delay in milliseconds. The range can be 1 to 65,535 milliseconds, and the default is 15. The following settings are required when configuring a dial-up modem link. Init string, the data string sent to the modem when the application starts. The range is 1 to 64 ASCII characters, no spaces. The default is ATC. Attention string, the data string sent to the modem to place it into command mode. The range is 1 to 32 ASCII characters, no spaces. The default is +++. Hang up string, the data string sent to the modem to cause it to hang up the phone connection. The range is 1 to 32 ASCII characters, no spaces. The default is ATH. Retry count, specify how many times to retry a failed connection before giving up. Increase the value to unreliable connections. The range is 0 to 30 and the default is 3. Retry delay, the amount of time to wait in seconds between retry attempts. The range is 0 to 3,600 seconds. The default is 3 seconds for client applications and 30 seconds for server applications. Idle wait time in seconds, the amount of time in seconds that must elapse without data transmission before the connection is terminated. The range is 0 to 3,600 seconds. The default is 10 seconds for client applications and 15 seconds for server applications. Auto answer, whether to enable the modem to automatically answer incoming calls. The default is enabled. You can manage the serial connections on the MCP on the Connection tab on the Configurations page. Each serial connection can be configured for device client or master station server communications using a selected protocol. The type of connection and the protocol you select determine the client or server application and related settings that are used for the communications on that serial port. A client-server map must be available before a protocol type is available for the configuration or client-server application. To add a serial connection, on the Connections tab, click Add Connection + button. On the New Connection window, select Serial Connection and select the serial configuration type from the list. Modify the settings for the new connection. Double-click a cell to modify a value. The fields under Configuration Settings are specific to the connection type. Click Save Configuration to save your changes. Each row under the serial heading of the Connections pane represents one connection through a serial port. As we mentioned above, the serial ports are indicated by numbers or a combination of letters and numbers, depending on the configured model in the order code in MCP Studio /device properties. The ports which are not available in the order code are shown grayed out. They're still available to configure to allow porting configurations across different serial ports equipped devices and without causing configuration errors. However, please note that in absence of the serial port in hardware, configured ports will naturally not operate. When converting G500 configurations to G100 configurations, the port assignments will be retained, as the system cannot automatically determine what to do with the extra serial ports. Because this conversion from a device with more serial ports, this operation will require a user decision and reassignment of serial ports in the lesser equipped G100. To modify a serial connection, select the connection in the Connections pane. Double-click or select a configuration parameter field, enter a new value in the parameter field, click Save Configuration to save your changes. If you select a different map file for an existing ID connection in the drop-down list, or when you save it as a different file name, when opened from within the Connections Map File Edit button, you'll be prompted with the following dialog. If you choose Retain, it'll apply the new map file. The home directory and print mappings related to the connection are kept unchanged for the points inside the map file, which were left with the same point ID. It's your responsibility to ensure the signals, in example, point ID meanings, defined by the previous map file are identical to the signals defined in the new map file. If you choose Break, it will apply the new map file. This will change the home directory, which results in invalidating all the existing point mappings that includes points selected within applications like the calculator, the alarms configuration page, and the system point manager. Mappings affected by this are referred to as non-existent. Choose Cancel if you want to abandon and revert to what was selected before. To delete a serial connection, select the connections you wish to delete in the Connections pane, click Delete Connections X button, click Yes to confirm deletion. In the result, the item is removed from the connections list. Click Save Configuration to save your changes. Deleting a serial connection will also delete configured devices. In addition, it could result in a home directory mismatch elsewhere in the configuration. The Applications Parameter window allows you to view and modify the protocol settings for a specific client-server connection. Application parameters are available on the Connection tab on the Configurations page. The settings shown may vary based on connection type and protocol selected. To view default application parameters, under Application Parameters, select Use Default and then click Show. The result should be the Application Parameters window opens. To create a custom application parameters profile, under Application Parameters, select Use Custom and click Create. The Application Parameters window opens. To modify a parameter, double-click the associated value and enter a new value or select from the drop-down list. When you're done, click Save. On the Save As window, enter a file name and click Save. Click Save Configuration to save your changes. To modify application parameters, under Application Parameters, select the Use Custom and select a profile name from the drop-down list and then click Edit. If this profile is created and has not been committed yet, the Choose Version pop-up appears. Select the version, committed, the most recently committed version, uncommitted, the version created but not committed yet. The Application Parameters window opens. To modify a parameter, double-click the associated value and enter a new value or select from the drop-down list. When you're done, click Save. On the Save As window, enter a file name and click Save. Click Save Configuration to save your changes. The MCP supports the security features for the pass-through supported in terminal server applications. This can be configured using the Serial Connections tab, Configuration Parameters, Secure Type option. The Secure Type options are available on the connections shown below. IEC 60870-5-103 multi-drop, Modbus multi-drop, generic ASCII client, SEL binary, MCP is master, terminal server. The secure type options are disabled, which is the default, or telnet. These connections are accessible through a TCP port on the MCP over a telnet session. The telnet option is considered unsecure, and the user assumes all responsibility for system design associated security risks when unsecured sessions are used. It's strongly recommended that SSL TLS, cryptographic protocol, or SSH secure tunnel are used for sessions across unprotected external networks. SSH secure tunnel. The MCP supports SSH Secure Tunnel, provides secure access to pass-through and terminal server connections. To know more on how to configure this type of pass-through connection, see SWM0101 MCP Software Configuration Guide under Miscellaneous Utilities, Pass-Through Connection, SSH Secure Tunnel Pass-Through Connections section. SSL/TLS. The MCP supports Transport Layer Security, TLS, which is cryptographic protocol that provides security for communications over networks such as the Internet. TLS encrypts the segments of network connections at the application layer to ensure secure end-to-end transit at the transport layer. The G500 supports TLS versions 1.0, 1.1, and 1.2. To use the SSL TLS option, you need to set up certificate-based mutual authentication. To know more on how to set up certificate, see SMW0109, Secure Integration of SCADA Third-Party Equipment with MCP. SSL TLS port, enter the port number that can be used to access the secure connection. The default is 50,000 plus X. Secure Application Parameters profile. The following parameters can be configured when SSL TLS option is selected. You can create and modify a Secure Application Parameters profile the same way as described in the last slide. On the Parameters tab, enable Insecure Authentication. When enabled, connection security features are not enforced. You should only enable this setting if alternative security features are available for the connection. The default is disabled. Session key renegotiation interval. The maximum amount of time in seconds that can pass before the connection session key is renegotiated. Frequently renegotiating the session key increases the security of the connection. The default is 900 seconds. Session key renegotiation count. The amount of data in bytes that can be transmitted between devices before the connection session key is renegotiated. The default is 100,000 bytes. Session key renegotiation timeout. The amount of time in milliseconds that the MCP waits for a response to a renegotiation request before the connection is considered timed out and is disconnected. The default is 2,000 milliseconds. On Issues tab, Peer. The text string that must match the common name as provided on the certificate provided by the remote device. Issuer, the name of the issuer that generated the certificate provided by the remote device. Select from the list of installed issuer certificates. Enable peer identity validation. The default is enabled. If enabled, connections are only permitted to devices that provide a certificate that contains a common name included in the list above and that was provided by the associated issuer. If disabled, peer identity validation is not performed. The default is enabled. On Ciphers tab. Cipher name, a list of ciphers supported by the MCP. When a connection is established with a remote device, a list of enabled ciphers is exchanged and the most secure cipher is selected to secure the connection. Select whether to enable the associated cipher. If the remote device does not support at least one of the enabled ciphers, the connection is not established. Permit null encryption. If checked, null encryption ciphers are permitted. If a null encryption cipher is used, the connection itself is unencrypted and is vulnerable to interception attacks. The default is disabled. Secure Protocol Default TLS 1.0. Select the TLS version used to secure the connection. Available options are TLS 1.0, TLS 1.1, and TLS 1.2. The default is TLS 1.0. A redundancy-dedicated link serial connection is required when configuring MCP system redundancy with serial heartbeat enabled. Device name, text description to identify the redundancy connection with default value -RLINKO. Auto start indicates that this connection automatically starts when the configuration is changed and reloaded or when the MCP reboots. The default is enabled. Port settings. The configured primary and backup ports for the serial redundancy dedicated link must match the ping cable connection. In warm standby. Redundancy, only the primary serial port may be used. In hot standby redundancy or hot redundancy, an optional backup serial port may also be configured. A redundancy switch panel serial connection is required when configuring MCP system redundancy with a switch panel wired present. Do not configure this if a switch panel is not wired, not present. Device name, text description to identify the redundancy connection with the default value RSWITCH0. Auto start indicates if this connection automatically starts when the configuration is changed and reloaded or when the MCP reboots. The default is enabled. Port settings. The port selection must match the RS-232 serial port where the switch panel cable is connected. Ensure that both MCP units in the redundant setup have connected the watchdog cable to the same serial port number. In a redundant setup, the MCP Configuration Manager synchronizes and configurations between the MCP units and the settings for redundancy dedicated link and redundancy switch panel will be lost if there's a difference between the two configurations. The MCP can be configured to provide transparent access, also known as pass-through, to connected devices using vendor-supplied PC-based programs. To enable a pass-through connection on a serial port without enabling a client application, the port must be configured as a terminal server. Following settings are used when configuring a terminal server. Device name, text description to identify the terminal server. The default is term 0. Auto start indicates if the client application automatically starts when the configuration is changed and reloaded or when the MCP reboots. The default is enabled. Port settings. See the port settings slide for more details on regular settings like baud rate. Flow control. Specify whether and which flow control is used. Options available are disabled, software and hardware. The default is disabled. Application parameters. See the application parameters slide for more details on how to create a custom profile. Basic network port. By default, the terminal server listens for incoming connections on port 8000. However, a custom port can be specified instead. Options available are Use Default and Use Custom. Default is Use Default. Custom network port. The network port where the terminal server listens for incoming connections. The range is 0 to 65,535 and the default is not enabled. Password authentication. If set to yes, the terminal server application requires a valid username and password before a connection is opened. The default is yes. Please note, if you configure one MCP to act as a terminal server for another MCP that is using virtual serial ports, the password authentication option must be disabled on the terminal server port. Minimum privilege level. The minimum user privilege level required for the user account providing login credentials. Options available are supervisor and operator. The default is supervisor. Secure type. See the connection security slide for more details on the secure type. Lastly, I want to thank you for watching this training content video. And if you're looking for more great content, take a minute and check out the Resources Hub on the GE website. You can do that by typing resources.gegridsolutions.com into your browser, or just click the link in the description of this video and it'll take you right there. Thanks so much for watching, and we'll see you next time.